so I'm demonstrating how it works. There is actually an issue. Just give me a second while I move my old man specs out of the way. Right. The power pack itself is a 30 volt, well, it's 31 volt power pack. I started experimenting with 30 volt Zener diodes and I was getting nowhere, but that's okay. Let me just move this stuff out of the way. I'm just moving these things. Right, so what we've done is basically, as you can see, we put the stuff on a breadboard. And so what I've done is, this is just, there's a ground connection which is just to this rail. These don't join together there. So, and this is just grounding out the first one, that one, which you can see is 0, and it should be. The rest are just getting a bit of noise, and I've actually connected here. Now, so this is a, whatever it is, 15, there you go. That's the last one, because I was just checking to see if they all work. First and last. Zener diode here, which is one of these geezers. It's a 20 volt Zener, right? So that means, right, in theory, we should subtract 20 volts from the power pack, and then that means the range between, because this is 5 volt input, so the range between 20 volts and 25 volts, right, should show now on this as a range between 0 and 5. And it does. Currently, because I was just experimenting a bit, let me turn torch off. So it's on 19.8, right? It's not actually fully accurate, but it's good enough for. Right, so 19.8, okay. I've set, there's a current limit set to 100 milliamps. It's the smallest it'll do because I don't want to blow stuff up. Right, so 19.8, and you can see, right? And now what I'm going to do is I'll take it to 19.9, and then you can see there's a little bit of noise there, yeah. And then we go to 20, and it's kind of around the 0 mark. Obviously, there's a bit of noise going up to, what's that, 0.1, because this is volts, so this is 0.1-ish, a bit higher, maybe even 0.2. Okay, right. Let's just take it up. Right, so I'll just voice it. Right, okay. So let's go back to 19.8, 19.9, 20.0, 20.0, 20.1, 20.2, 20.3, 20.4, 20.5. Right, so now you can see that is actually around about 0.5. So the 20 volt Zener here is subtracting its 20 volts from the power supply. Oh, it's 0.4. What happened? Right? It's subtracting its 20 volts from the power supply voltage and giving us something else. Obviously, there's an accuracy because these are not designed to be this accurate. I just wanted to point out that there is a. If I can get a touch on. This is a 10K. What happens basically is there isn't enough load on the Zener diode for it to actually reverse bias properly, right? And so what I've done is I put a 10K there between the pin and the ground to actually put a current through the diode, a reasonable current, so that it can actually gate properly. It can its PN junction can operate properly, and we can get its Zener voltage. Because the actual input to the Arduino isn't enough. It's like microamps, and so it's just making it noisy. So I put a 10K on there just to give it some load, small amount of current load, yeah. And then that means you get the Zener voltage, right? So obviously this, as you can see, this is the input. It goes to there. And that's to the to reverse bias the diode, and then we're measuring the voltage at the Zener level, and we've got the resistor in there as well to give it some load. And this is kind of measuring that circuit, essentially, isn't it? Essentially. So now we got, okay, let's turn the light off again, and so now we got sort of roughly 0.5 volts for 20.5. So I'll just razz it up again. Let's take it up to 22.5. Okay, so 22.5 minus 20 volts should be 2.5. Huh? Okay, so it's higher than 2.5. It'll probably round up to 2.6. Right, and then we go up to say 24.0. 4.0. Yeah, 24.0 minus 20 is 4.0. And then we'll go up to 4. Let's go to 4.5. Yeah, 24.5 obviously, but because of the 20, we can just ignore that now. Yeah. And if we go to 24.9, yeah, it would round up to it, wouldn't it? And 25 volts. There you go. So, and it's obviously going to round up to 5 volts there. And then if I take it up to 25.1, bam. Now, when it was actually working, when I just had it on the power pack running at that, it took 5.1 volts to actually get it to register its full scale deflection here. Yeah, so I'm guessing because we've got long wires here and there's all sorts of other stuff, there's going to be noise. And it worked the other way as well. When in actual fact I was using low voltage, it kind of registered slightly high. So we've obviously got a bit of hysteresis in there as well. But as you can see, 25 volts. Now we subtracted the 20 volts from the 25 volts and got 5 volts. Yeah, ish. Let's just take it to actually 25 volt proper. There we go. You see, that's even nearly near, isn't it? Look at that. That would round up. You know, if you just do 2 decimal places, 1 decimal place. Sorry. Yeah. So it's working. This is a analog computer, essentially. Really simple one, but it is. We are subtracting a value from a voltage to give another voltage, aren't we? So this is essentially how you do that metering of batteries. Because if your battery is a 25 volt battery, right, and you want to see what the voltage is within a certain range, like say you had a 5 cell battery, right, you could then quite accurately measure the voltage of the last cell, can't you? Yeah, notwithstanding the voltage of the rest of them. Yeah, but it does do that, so you got it right. So you can measure, seriously, you can measure 25 volts now quite accurately, you know. What I want to do though is measure 50, but that power pack won't do it, but this one will, because this one goes up to 120. So what I'm going to do now is connect that one in and this one, and we'll try and get the highest voltage, so we can actually measure, quite accurately measure the full voltage, which is 52, but I'd probably take it up to 60. Okay.